Hi, today I'm going to tell you a few words about signal flow graphs. Let us consider a symmetrical electrical network like this. In order to solve this network, there are two kinds of general techniques. One among them is applying KVL or KCL to the network. So, if we apply KVL or KCL to the network, we will get 5 integral differential equations. To solve these integral differential equations, we apply Laplace transform or any other transformation tool to get 5 linear algebraic equations. So, as you know, any transformation tool is used to convert these integral differential equations into linear algebraic equations. But this really appears to be mess. So we may opt second technique, that is matrix technique. Even in matrix technique also, it makes little bit complicated to solve this network. So now we are going to introduce the importance of signal flow graph. A signal flow graph is defined as the graphical representation of linear algebraic equations between input and output. A signal flow graph is defined as a graphical representation of set of linear algebraic equations between input and output. So it represents the set of linear algebraic equations between input and output. And these linear algebraic equations will represent a system. The signal flow graph analysis is very easy as compared to solving the linear algebraic equations or integral differential equations. And the signal flow graph analysis is derived or developed basically to avoid various complicated mathematical equations or calculations. So, what is the purpose of signal flow graph first of all? The main reason for signal flow graph is to get the overall transfer function of a system, and we may get the ratio of any two nodes without any modification in the signal flow graph. First of all, what is a node? The nodes in the signal flow graph are variables. They may be whether currents or voltages. So now let us solve some problems in order to understand the construction of signal flow graph. Our first problem is y2 is equal to 10 into y1. I am repeating, y2 is equal to 10 into y1. There are some rules to construct the signal flow graph. One among them is the variables which lies in the right side of the signal of the equation is called an input variable. The variable which lies in the left side of the equation is called output variable, and the branch of a signal flow graph always flows from input to output with a path gain of 10. So here y1 is called the input node, y2 is called the output node, whereas 10 is called the path gain or transmittance. It is called path gain or transmittance. And y1 is also called source. The node which acts as input is known as source, and the node which acts as output in the signal flow graph is called sink. I hope you understood the first problem. So now let us practice the second problem. Start practicing with me such that you will understand the concept very clearly. And our second problem is y4 equal to 2y1 plus 5y2 plus 10y3. I am repeating it again. y4 is equal to 2y1 plus 5y2 plus 10y3. I think you are now ready to solve the solution, solve this question. Okay, now let me solve the solution, solve the problem. Here, as I said earlier, these variables are on the right side of the equations, so they are inputs. y1, y2, y3 are inputs of the system, and y4 is the output of the system. So y1, y2, y3 are sources and y4 is a sink. And 2, 5, 10 are path gains. So now let us construct a signal flow graph of this data. Always start with inputs y1, y2, y3 and end with output, that is y4. Now, as I said earlier, the branch of the signal flow graph always starts from input to output. So from y1 it starts with a path gain of 2, and from y2 to y4 with a path gain of 5, and from y3 to y4 with a path gain of 10. This is how we can construct a signal flow graph for the above system. Now, this signal flow graph is drawn based on a rule which is called additional rule. Additional rule. This additional rule represents many to one transmission in a communication. This additional rule represents many to one transmission. Similarly, I hope you got the same answer, right? Okay. Similarly, if let us consider y1 as an input and y2, y3, y4 are outputs. That means y1 is a source and these three are sinks. I said earlier, always the branch flows from input to output. This signal flow graph is drawn based on one rule called transmission rule. And this transmission rule represents the single mode to many. The additional rule represents many to one and the transmission rule represents single to many transmission. I hope you understood the basic construction of signal flow graph. Now let us increase our level. Let us solve a level 2 question of constructing signal flow graph. One is construct the signal flow graph to the given set of linear algebraic equations. Construct signal flow graph to the given set of linear algebraic equations. They are y2 is equal to y1 plus 2y3 and y3 is equal to 3y2 plus 4y4 and y4 is equal to 5y3 plus 6y4 plus 7y5 and the last one is y5 is equal to 8y4 and sorry it is not visible 8y4 plus 9y2 9y2. So construct the signal flow graph to the given set of linear algebraic equations and the four algebraic equations are given below. Try to solve the question. So as I said earlier, we have to consider the definition of signal flow graph in order to solve this problem. The definition of signal flow graph is: the signal flow graph is a graphical representation of set of linear algebraic equations, and that set of linear algebraic equations represent a system, right? So you should not solve the equation individually. You should consider it as a system. So now, let us draw the signal flow graph. Let me draw in the top of this. First of all, as I said earlier, try to start with inputs. See what are the inputs. In this equation y1, how many variables are there? y1, let us mark without confusion. y1, y2, y3 and y4 and y5, and the highest variable is y5. So try to put the variables as stated earlier: y1, y2, y3, y4, y5. So these are the variables, these are the nodes. As I said earlier, what is a node? A node is a variable. It may be current or voltages in a system. So now let us draw the system. From y1 to y2, y1 acts as a source and y2 acts as a node, a sink. See, this is y1, this is y2, with a path gain of 1. Understood? Okay. Next, y2. From y2 to y3, is there any path gain? First of all, draw the forward path. Let me define what is forward path, or whatever it may be, loop or whatever it may be. First of all, try to solve only forward paths like this. Go only straight line path. That is, now y2 to y3, is there any path? Yeah, see, y2 to y3 with a path gain of 3. So y2 to y3 with a path gain of 3. And now y3 to y4, see here it is a written y3 to y4 with a path gain of 5. And now y4 to y5, is there any y4? Yeah, see here, y4 to y5 with a path gain of 8. Now our major task is completed. So now let us construct the forward paths are completed. See, any other things are missed? No. So y5 to y1, nothing is there. Okay, leave it. Now it is our duty to construct a forward path. What is forward path? First one, it is a path from input to output. So we did that: input to output, 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 and here input to output, input to output. Everything is covered. So now it is our duty to construct. See, yeah, there is another path here. See, from y2 to y5, y2 to y5. This is another forward path with a path gain of 9. Okay. And now, is there any other forward paths like this? No. There are no nothing left, no forward paths. Okay, now it is our duty, next duty, to construct loops. What is a loop? A loop is a path that terminates on the same node where it is started. A loop is a path that terminates on the same node where it is started. Okay, now let us prove our definition. See, there is y3 to y1. Any feedback path? Yeah. See, y1 to y2 finished, and y3 to y1. See, this is a node y3 to y1 with a path gain of 2. See, what I did is I draw first of all forward paths, and now I am drawing feedback paths. Okay, y3 to y1, and next y4 to y3. This is y4 to y3 with a path gain of 4. Finish. Next y4 to y4. See, y4 to y4 with a path gain of 6. y4 to y4 with a path gain of 6. Okay, next. Anything else still? y5 to y4 with a path gain of 7. y5 to y4 with a path gain of 7. Okay. Still anything else? Nothing, right? Okay. So now we constructed, see, y2 to y5, y2 to y5. Yeah, we had already done it. Yeah, now in this set of equations, first what I have done is I have traced out the nodes 1, 2, 3, 4, 5, y5 nodes, and after that I draw only forward paths, and after that I draw feedback paths, and everything I have completed, including forward and feedback paths. Now it is our duty to trace out the loops in the network. What is a loop? A loop is a path that terminates on the same node where it is started. So now let us start the loop. Okay? Yeah. First loop. See, what is it? y2, y3 to y3 to y3 to y2. Okay. Thank you. y3 to y2. y3 to y2 with a path gain of 2, right? Okay. Okay, first loop. See, this is a node. A loop definitely will have a feedback path. Okay. So this is a node. It started like this. It went and touched a node. Again it returned. So it returned to its original place. What is a loop? A loop is a path that terminates on the same node. A loop is a path that terminates on the same node where it is started. So this is one loop. Okay, this is one loop, and let us consider this loop as L1. Okay, yes. Now let us consider second loop. Find it out. This is a node. A loop is a path which will terminate at the same node where it started. A loop is a path which will terminate at the same node where it is started. So this is another loop. Understood? So this is another loop. Next. Similarly, a loop is a path which will start and terminates at the same node where it is started. So this is loop 3. So how many loops we got? L1, L2, L3. See, still any other? Yeah. Yeah, remind your definition. How many times you tell definition, that many practice it will be, that much practice it will be. So it is a loop, it is a path which travels and terminates at the same node where it is started. So this is L4. So these are the loops in the network. But we have to see carefully while writing loops in a signal flow graph. See, there is another loop, that is, this is one node. It starts here, it travels, and it comes here, and it comes here, and it travels in this path, and again it touches the node. I hope you got it. See, This is the major problem in signal flow graphs. You have to carefully pick up the loops in the graph. Starting point travels like this, it travels like this, it travels in this path, it travels in this path, touches the node, travels in this path, touches the node, travels in this path, and finally terminates at the node where it started. So this is loop 5. So this is the construction of signal flow graph. In my next lecture, I'm going to deliver the lecture on Manson's gain formula and some basic shortcuts to draw the signal flow graph for complicated networks. Thank you one and all for giving me this valuable opportunity. Bye.